In South Africa, the transportation of goods by trucks adds to the traffic problems on our roads. A 10,000 kilogram truck travels up a straight inclined road of length 23 meters at a constant speed of 20 kilometers per hour. The total work done by the engine of the truck to get there is 7 times 10 to the power 5 joules. The work done to overcome friction is 8,5 times 10 to the fourth power joules. And now here we need to calculate the height h reached by the truck at the top of the road. Here's the truck traveling at a constant speed of 20 kilometers per hour as it actually goes uphill there. All right. And to do this question, then we need to calculate the height h. So I'm going to move this a little bit to the side. So we're doing 6.1. And we're going to have 6.1. So to do that, we need to do W net, which is the change in potential energy plus the change in the kinetic energy. And therefore, we have W net, which is the change in potential energy is mgh final minus mgh initial plus a half. The change in the kinetic energy is mvf squared minus half mv initial squared. Now to find the W net, so we have 7 times 10 to the fifth power minus 8,5 times 10 to the fourth power is equal to 1,000 into 9,8 times h final plus 0. And therefore, if we continue, we're able to find out that our h final is 6,28 meters. So the height reached by the truck will actually therefore be 6,28 meters there. Okay, and then now we proceed. So in other words, we were effectively solving question 6.1.1. Okay, so this was basically question 6.1.1 there. All right, that's what we're solving there. And then now we're going to do 6.1.2. We want to calculate the instantaneous power. All right, so to do that one, it's done in a very similar fashion. And this is how we're going to obviously proceed to do it. Okay, here is the question 6.1.2. We need to calculate the instantaneous power delivered by the engine of the truck. What is the instantaneous power that the engine of the truck delivers? 6.1.2. So to do that one, so we're going to do 6.1.2. We need to first calculate the force. So we'll say work done would actually therefore be the force by the engine of the truck, delta x cosine theta. Now the work done by the engine of the truck is 7 times 10 to the fifth power f into, you can clearly see in this case the actual length of the track, the path followed by the truck is 23 meters. So that will therefore be 23 meters here, 23 cosine of 0 degrees. And then if we solve these, it will therefore be 3,04 solving for f times 10 to the fourth power newtons. So this will be the driving force, the applied force. And after having obtained the applied force, we proceed to find the average power. That's the instantaneous power. So in this case, what is the applied force by the engine of the truck? So it will be 3,04 times 10 to the fourth power into um, um, 20,000. 20,000 because now we are dealing with the 20 kilometers per hour, and we're trying to convert 20 kilometers per hour um, to meters per second, the SI unit of speed. So as a consequence, then this power is 1,6 times 10 to the fifth power watts. Okay, watts. So this would be the instantaneous power required, 1,6 times 10 to the fifth power watts. And then the next question is the very last one. And the very last one is obtained as follows. So we're going to do the last one. The last one is pretty straightforward because they're saying arrestor beds are constructed as a safety measure to allow trucks to come to rest when their brakes fail whilst going downhill. Write down two design features of such arrestor beds. Okay, the arrestor beds will therefore be given as follows. So in 6.2, you therefore have that the surface must provide sufficient friction like sand. Okay, that's one design feature. The next design feature, this must be long enough, long enough for vehicle to stop. All right, so we're done with this question, and thanks a lot then, everyone. A goodbye to you.